All right, let's dive right in. Today, we are mapping out the exact path to becoming an AI agent architect. This isn't just another job title, it's one of the most critical roles in tech, period. So if you're ready to stop just using AI and start actually building with it, this is the roadmap you've been waiting for.
So, the first thing you have to get your head around is that the game has totally changed. The whole era of prompt engineering, just having a clever chat with an AI, that's over. A brand new, way more powerful discipline is here, and it's all about building autonomous, intelligent systems.
And this quote right here, it just cuts right to the heart of it, doesn't it? The market isn't paying for clever prompts anymore. No way. It's rewarding engineers who can actually build systems. Systems that can reason, plan, execute their own tasks, and, this is key, fix their own mistakes. We're going from being passive users to active builders.
And you can really see that shift right here. In the past, it was all about these stateless chats, right, where the AI forgets everything you just said a second ago. The future is all about stateful systems, systems that remember context. This allows them to actually execute complex tasks reliably and get predictable, deterministic results. We're moving from just chatting to actually executing. It's a huge leap.
Okay, so how do you actually build these incredible systems? You're probably thinking it costs a fortune. Well, here's the best part. You don't need a massive budget. In fact, we're about to walk through a whole stack of tools that are either open source or have super generous free tiers. This means anyone, and I mean anyone, can get started with enterprise-grade AI development.
At the very heart of our toolkit is LangGraph. Now, I want you to think of this as the nervous system for your AI agent. It is the industry standard for a reason. It lets you build your workflows as graphs that can have loops. And those loops, well, they are absolutely crucial. They're what allow an agent to try something, check its work, and if it's not right, loop back and try again. That's self-correction.
This table really clears things up. You've probably heard of tools like CrewAI, and look, they're great for what they do, which is mostly rapid prototyping with this fun role-playing idea. But LangGraph, that gives you the low-level, deterministic control that you need for serious production-ready engineering. Let me put it this way. CrewAI helps you build agents that talk about doing work. LangGraph helps you build systems that actually do the work.
Next up, let's talk connectivity. This is the Model Context Protocol, or MCP, and the analogy here is just perfect. It's the USB-C of AI. You know how before USB-C you had a million different cables for everything? That's what connecting AI to tools was like. MCP changes all that. It creates one standard way for your agent to connect to any tool or data source.
And it works with this really simple, elegant architecture. Your agent is the host. It uses a client to connect to a server. And that server is just a little independent service that exposes your tools. What this means is you can build a tool once as an MCP server, and then any agent that speaks MCP can use it instantly. It's modular, it's reusable, it's just incredibly smart.
So for the actual brain of our agent, we're going to use a really clever hybrid strategy. For most of our day-to-day development and testing, we'll run powerful models right on our own machines using Ollama, models like Llama 3.2 and the reasoning beast 5.4. Then for those really heavy-duty tasks that need a massive context window, we tap into Google Gemini's free tier, which is just unbelievably generous. Best of both worlds?
Okay, having the right tools is one thing, but knowing how to use them, that's what separates the pros from the amateurs. So let's talk about the architectural blueprints for building genuinely smart systems. We're talking about agentic design patterns.
The first pattern is a big one, reflection. This is how you build an agent that doesn't just make a mistake and give up. It learns. The agent generates some work, then a totally separate reflector node acts like a critic. It looks for flaws, and if it finds any, it loops back and makes the first agent try again, but this time with the critique as guidance. The quality of your final output just skyrockets.
Next, we've got the hierarchical supervision pattern. I just call it the boss pattern. See, for really complex tasks, a single agent is just going to get overwhelmed. So instead, you build a supervisor agent that acts like a project manager. It takes the main request, breaks it down, and delegates smaller tasks to specialized worker agents, a coder agent, a researcher agent, and so on. This is how you build systems that can tackle really big, ambitious projects.
And to make our agents truly intelligent, we have to give them a long-term memory. With episodic memory, every time an agent successfully completes a task, it saves a little summary in a local database. So the next time it sees a similar problem, it can just recall how it solved it before. This means your agent literally gets smarter and more efficient every single time it works.
So you've learned all these concepts. How do you actually prove that you've mastered them?
Well, you build something. Theory is great, but a real, working, sophisticated system, that's what shows the world you are a true architect.
And here is a killer portfolio project idea: the self-healing code review agent. This isn't just an agent that spits out some code. No, this is an agent that acts like a senior engineer. It writes code, it tests its own code, and it fixes its own bugs until the code is perfect.
And just look at this architecture. It brings everything together. You've got a coder node that generates the code, a tester node that runs all the checks, and then that reflector node we talked about, analyzing any failures. If the tests fail, it doesn't just crash, it loops back, handing the bad code and a suggested fix right back to the coder. This is that self-correction pattern in beautiful action.
All right, let's talk about turning this all into a career, because having the skills is really only half the battle. You have to know how to translate them into a high-level job, and that means rebranding your experience and learning how to nail the new kind of system design interview.
This right here is so important. You have to signal to recruiters that you're a systems thinker. So you're not doing prompt engineering anymore, you're designing system prompt architecture. You don't build chatbots, you perform multi-agent orchestration. This pivot in your language is absolutely critical for positioning yourself as a true architect.
And you better be prepared, because the interviews are changing too. You're not going to be asked to design a URL shortener anymore. No, you're going to be asked to design complex, autonomous systems. The challenges are completely different, and your answers have to be way more strategic.
So let's look at a couple of A-plus architect-level answers. When they ask how you'd prevent infinite loops, you talk about using state machines and setting recursion limits. For data privacy, you describe the PII tokenization pattern, a way to replace sensitive data with safe tokens before it ever touches an AI model. These kinds of answers prove you thought through the hard, real-world engineering problems.
So there it is. The path is laid out. The tools are free. They're available to literally everyone. Right now, you have the same power at your fingertips as the big enterprise R&D teams. So really, the only question left to ask is, what incredible system are you going to architect first?